Hello, everybody. As we stand on the precipice of new scientific discoveries, it is not an overstatement to say that we inhabit the world sculpted by the hands of science, both materially and intellectually. And the pioneering work in the realm of click chemistry, the field that has revolutionized our the way we understand and interact with the molecular world, is a testament to this truth. For me, it's a great honor to be engaged in the dialogue with the 2022 Nobel laureate in chemistry, Morten Meldal, a luminary whose contributions have illuminated the path of scientific progress. Hi, Morten.
Hi.
Grateful on behalf of my community, I'm deeply grateful to you for your willingness to share your insights and time with us today. Thank you so much.
Thank you for the invitation.
Yeah, thank you. So the first thing I would like to inquire, how do you see the field of chemistry evolving in the next decade, and what breakthroughs do you hope to see here?
I think that what chemistry will bring over the next 10, 20 years is probably a better connection between the actual complexity of nature and our understanding of the chemistry world, the chemistry bondings, the chemistry aggregations and complexations, and so on. So there will be a much more holistic view of how chemistry leads to the complexity we have in our real world.
Okay, thank you. Really good. And your work with the click chemistry has had a significant impact on the drug discovery. What other areas do you see the click chemistry having potential in the future?
Well, I think that click chemistry has potential everywhere where you want to link two things together. And that's actually the power of the click chemistry, is that we can link almost everything on the molecular level together into larger units. So we can make architectures that were not possible before. And that's where click chemistry has its, the force. So you can imagine surfaces you want to cover with an antenna that can capture photons, and another one that can take that energy and make electrons. So you have a photovoltaic cell, or you have a solar energy cell that can actually be down to the molecular level and can be used as energy for controlling other things that are also single molecule events. So I think that there's a lot of future in material science using click chemistry, besides the pharmaceutical, progress that we have made over the last many years.
Yeah, that's really amazing that we can see new technologies which could be affordable for more people and other things we can do. Okay.
Yeah.
You have received numerous awards and honors throughout your career. How do you stay motivated to continue pushing the boundaries of scientific research even after achieving such a great success?
Well, it's not really a matter of having the ambition to push boundaries. It's because I really love the chemistry. I like to work with it, and that's how this whole thing has developed. Because when there's something exciting, I can't help going to the lab and working, day and night. So it's just because I like it.
I see. The main thing is to enjoy the journey.
Yeah, exactly. And I think that's how most discoveries are actually made, because I don't think that the scientists who really make the great discoveries, they don't do things that they expect results from in a particular way. They do new things which are like playing in a sandbox, creating completely new kinds of insight into chemistry.
Yeah, I see. But in this regard, have there been instances where your research did not yield the expected results, and how did you deal with them?
And that's almost every project you start starts out by being impossible, and it has to be like that, because otherwise it wouldn't be a challenge to go there. And the challenge is that you have an idea, you try to work on it, and it doesn't succeed. So you look around in your project, and then you find, oh, something else happened, which is really, really interesting. And that's happening all the time. So it also happened with the click situation where we were looking for another reaction. We were looking at another reaction when this reaction happened, and we started to investigate this reaction, the click reaction.
And do you agree that any big discovery is happening because of the serendipity? And if so, why it is so crucial to rely on it?
Almost all of them.
Really?
Yeah.
Wow. Yeah, it's really amazing. Okay, and how do you collaborate with other scientists to achieve common goals and breakthroughs in your field?
Usually when you are a scientist and you want to collaborate, you have to actually not look for colleagues who do the same, but colleagues who do something completely different. Because then you can more or less be complementary in the research and help each other out rather than trying to do the same thing. So I'm always looking for collaborations, for example, structural studies or bio studies or something like that. And then I try to be the chemistry anchor in those collaborations. So that's how that works, I think, in general in science. If you try, I've tried that. If you try to collaborate with people who do exactly the same as you, it's not very fruitful. It's usually creating all sorts of blocks in the collaboration.
Yeah, there should be the opportunities to be diverse as much as possible.
Yeah.
Okay, Morten, you have a passion for building guitars. How does this creative outlet influence your work as a scientist? And also, oh, yeah, that day, really cool, made by your hands.
Yes.
Very,
So
very
this is
nice.
an interest. I'm playing music, right? So I have had this interest, and I got, when I was young, I helped a forester to put his forest on a computer, and as a thank you, he gave me an oak tree.
Yeah.
A huge oak tree that he cut out in slices of the right, thickness for a guitar. So I've used that wood for making guitars over the years.
Awesome, really nice. A great pleasure to hear that from you. And probably you have some, key strategies of combining family life with the work and research. Something.
Yeah, so I think that you if you only do your work, you're actually not achieving too much. You have to do other things in order to get inspired, in order to change your way of thinking, in order to, be able to imagine other things than just your chemistry, because that feeds into each other, the way that you are imagining things. And the chemistry world is really an imaginary world. We have to be able to imagine the molecules as three-dimensional shapes that interacts and so on. So I think it's important that you do other things that strengthens your ability to think abstract and in images.
Okay, thank you. In regard to scientific publications, how do you tackle the challenges and demands associated with the increasing and more increasing volume of scientific research and publications?
Well, it's almost coming automatically when you are, if you're interested in your work and you do some exciting things. The first thing you want to do is, of course, share it with people. So you make your publications. If it's one more or less doesn't really matter. It's more important what is in the publication. I think that too many people are concerned about the number rather than the content. And I also think that it's important to take your time when you do research. A lot of the stuff that is out there in the literature is impossible to repeat. And this is, of course, a big problem for science. So I think that it would be very good if everybody were more honest about their research. It's not easy to do research, and it's not always successful. So you have to be very honest about that when it's not. Or when it's limited success, then it's important to state that it's limited success, because the success is still there. I mean, if you're making a new molecule, you're making a new molecule, and that's a big story. It's a much smaller story whether it was made with 5% or 90% yield, because the big story is you have a completely new molecule that probably never existed before in the universe.
It's always a matter of taking the time for quality research.
Yeah.
As sometimes scientific publications are, if we take the matter of low quality publications, it means that people are not, we see that people not paying too much attention to their research, actually.
Yeah, and low quality publication has nothing to do with you know,
with the future discoveries, probably.
No, with the quality, general quality of the journal, and general quality of the actual publication is not always coherent.
Yeah.
In terms of citation index, for example.
Yes, you're right. That's true. Okay. The current rise of artificial intelligence, are you observing anything, and how do you think it may have an impact on the further development of chemistry as well?
There's no doubt that chemistry is probably the place where artificial intelligence can do most good, but also probably a lot of bad. But I think that we should be very careful with artificial intelligence, in particular because artificial intelligence is not only good for chemistry, it's also excellent for making very swift surveys of data in the defense industry, in the defense, you know, in the conflicts that occur around the world. And if we should utilize that optimally, or if one should utilize that optimally, you have to give the program some decision-making capacity. And I think that is extremely dangerous, and that's going to happen probably. So I think that artificial intelligence can be extremely good in handling data and searching out patterns in your data collections and so on. But I also think that there's a real danger that we have to consider before we get too far into it. I mean, we already have let the devil loose here, so it's going to be...
But in any case, it's not a matter to replace humans with artificial intelligence, because
I think it's going to be supportive to humans. I mean, every single discovery over time has proven ability to help people and ability to be used in a bad way, and it's all up to humans how we are actually utilizing technology. So the technology itself is not good or bad. It's the same with all the other technologies, GMO, for example, or nuclear power and so on. All of those are just fantastic discoveries and inventions. And it's just up to humans to use them correctly. So it's our ability to steer in a world of conflict that really matters.
Yes, that's true. Thank you. In your opinion, what are the biggest challenges in the scientific community faces today, and how we can address them? And also, I'm really curious about Denmark. What are the challenges in science it may have now? How do you think?
Let's take them one at a time. And the first one was, I didn't hear it. You said two things. The first one was
about the biggest challenges in the
biggest,
community.
So that is of course the environmental problems. We have only seen the very beginning of this problem. It's a huge problem, and it's going to increase dramatically over the time. I think it's very difficult for science to help in any other way than just measuring the consequences of what we are doing. It's not science that is going to stop us using the wrong resources and so on for producing energy. That's controlled by the financial markets and politicians. Politicians are too short-sighted for making the right decisions in the environmental crisis, and that is a real problem. So because of re-election, or because they are not having enough brain capacity, I don't know what it is, but we don't do what we should do in order to prevent the disaster that is ahead of us. So I think that chemistry can, of course, offer some help. Science can offer some help with renewable energy technologies. It's going to come slow, too slow for the actual rescue of many people. There will be a great suffering because of this. Is my belief. It's not because I don't want to be positive. It's because I'm just looking at the reality right now.
Yeah,
it's not an easy task to steer this. Every second, third day, you see some catastrophe around the world, and people just have to acknowledge that this is actually happening in order to make politicians and financial people make the right decisions in this scenario.
yes. Unfortunately, sometimes just capitalistic things happening and prevailing more rather than solving big problems.
But again, I think that science will play a vital role in trying to control this, because science is the one that can unanimously decide that there's a problem because they have the data to show and prove it. And I also think there might be some solutions ahead, in particular in renewable energy area, where we can make it much more accessible and much cheaper. We can we can make technologies that work together, like producing the energy, storing the energy, distributing the energy, and so on. And I think that will happen because there's such a great pressure at the moment, particularly maybe even the stupid conflict in Ukraine can actually have a positive effect on that, because we don't get this Russian gas and oil anymore, and I think that's a very good thing. That will allow us to develop the alternative energy strategies.
Yeah. It's a good motivation for really big changes.
Yeah.
Yes. And especially for Denmark, do you think something special?
Well, Denmark is a very lucky country, actually. We are very privileged in Denmark because of our taxation system. That sounds funny, but it's true. Because of our very high taxation here in Denmark, I think that's key to our success. The foundations in Denmark formed because it was better to do that than other things because of the taxation. So we have these huge foundations that are supporting research, and we are doing tremendous progress in all sorts of areas because of that. So scientifically, I think that's one of the best places in the world right now. You can get the funding that is needed to do very exciting research. And the foundations have also matured significantly. So they now support research in a different ways, more productive way, you may say, for fundamental research results.
I see. Good to hear that. Really good. Okay, and what advice would you give to those interested in pursuing a career in chemistry or in science in general? And what traits do you believe are essential for success in this field?
So science in general, but in particular chemistry, is very much a field where you need to understand science in terms of math, in terms of other things, in particular in terms of images. So science is in particular chemistry is a field where you have a three-dimensional world of molecules that interact and affect a lot of activities. It's both in the inorganic, in the organic, and in the life world. You have all of these interactions that we need to understand, and that's where our challenges are right now. How do we get a better understanding of all of that is going on? So I see that science has a great future, actually, in trying to make the society at large understand chemistry. And when that happens, it has to be by making people understand what is happening in this imaginary world down to the molecular level. So I think that we should try to educate our children in chemistry. Chemistry is all around us. It's everything actually around us. And our understanding of that is just as important as reading, writing, and math. So I have a program where we're trying to establish a video teaching system, which should start from first grade in order to increase our knowledge of chemistry in particular. I think that careers in chemistry very much depend on your imaginary understanding of this invisible world. So the chemistry that I can see it from my students, for example, that when they have this framework of images of the chemistry, it's much easier for them to understand what actually is going on and to handle the design processes, the synthesis, and all of that they have to carry out in the laboratory. So I think that this is a very important thing to try to disseminate to not only those who will choose a career in chemistry, but to the entire population. So that's what we will try to do.
Okay, I see. With the students, do you use the how extent do you use the virtual reality or augmented reality technologies? Do you use that?
Well, I wouldn't call it augmented reality. It's just molecular modeling, computer programming. It's making this visible by the means that we already have. Has been a fantastic development of visualization techniques over the years. And we can now calculate and show molecules like they were real things, you know, and they are, of course, but become reality to the children and to, you know, also people starting their studies.
Yeah. Now the youngest one are really in the position they can be attracted to new technologies and science and to fall in love with that.
Yeah,
as much as they can.
Yes. So we would do videos that show, you know, what it is when you travel into the hydrogen molecule. Look at the nuclei, look at the electron cloud, how that looks, and then it meets another atom of hydrogen and they form the hydrogen molecule. You see how the electrons change. They then meet an oxygen and react with that oxygen, and you see the water forming. You can split the water by electrolysis, and you will go out and in from macroscopic world to the molecular world again and again, and teach the children that there's a real channel of communication between what we see around us and what we can imagine is happening in these surroundings on a molecular level.
I see. That's fantastic. Okay. Dear Meldal, it's been an absolute pleasure speaking with you today. Your insights and experience are truly inspiring, and I'm sure our audience will appreciate it as much as I do. I'd like to wish you continued success in all your future endeavors, and we'll certainly be following your work with a great interest. And thank you once again for your time and for the significant contributions you have made. Thank you so much.
And all the best to you and Ukraine.
Thank you. Thank you so much. Great pleasure to hear.